Welcome to class today, pre-cal students, on Tuesday the 12th. Hope you guys are doing well. Hope you're ready to learn some math today. Good to see you guys yesterday here at the house, and hopefully your tests are going well. I'm here to help you. I'm a phone call or an email away, and you're welcome to come over and get help as long as you set that up. The only thing I ask is you give me at least a day's notice so I can check and make sure that I can fit you into my schedule, but usually I will be able to. Here are some announcements real quick to take a look at. We will have a quiz this weekend. I'll be emailing that to you Friday or Saturday. Keep up on the integrity sheets. I was not disappointed at all that no one had completely done all their homework. I know that there was a big soccer tournament, and I know you guys get behind. You have jobs you have to work and stuff like that. That's fine. However, remember, first of all, you lose 5 bonus points on your quiz. So the next quiz you guys take, you don't get the 5 bonus points. And then secondly, it just hurts your grade. So please stay on top of your integrity sheets. When you come to my house in 2 weeks, once you walk in the door, you'll not be allowed to watch any more videos for credit or do homework for credit. Everything has to be done, and you'll have to hand me a sheet of paper with everything written down that you've done, okay? And we're going to do that the rest of the year. Tests are due by tomorrow. I will be taking 5 points off for those that do not contact me or bring it by my house. Whichever it may be. So please take care of that. If you have any problem with that, if you're behind, just talk to me, okay? Call me, email me, and let's talk it through, okay? Tests are due by tomorrow. Let's go ahead and jump right into this. I like to teach as quickly as possible. And leave you time to work on your homework. So let's get after this right away, okay? Grab your notebooks, pencils, pens, calculators, books, whatever you need, and let's get started. We're going to spend a couple days now looking at a topic called complex numbers. Complex numbers. The lesson number is 7.3, and the date today is the 12th. Now you might wonder, how did we go from trigonometry to complex numbers? And you'll see as we wrap up the class period today, we're going to learn to write these complex numbers in trigonometric form, or trig form. And that's the tie to trigonometry, okay? This is our last chapter of trig. We've done really well, and so let's finish this chapter up and be done with trig for the rest of the year. All right, complex numbers, lesson 7.3, and today's the 12th. Before we get into complex numbers, I really need to explain what an imaginary number is. Now you'll see why in just a second, okay? You do not need to take notes on this. You can if you want to. It's up to you. The square root of 4 is 2. We know that, okay? Because 2 times 2 equals 4. However, if I ask you to find the square root of negative 4, there really is no answer. Now you might say, well, Mr. Earhart, I know what the answer is. It's negative 2. Not really, because if you claim the answer is negative 2, then if we take negative 2 times negative 2, we should get negative 4. And we don't. We get positive 4. So what I want to show you here just for a second is it's impossible to take the square root of a negative number. It can't be done. So what mathematicians have done is they have come up with a way to symbolize taking the square root of a negative number. And what they do is this. They say, okay, if I take the square root of a negative number, I'm just going to make it positive as long as I put an I on the outside. And that I represents the negative sign. And then the square root of 4 is 2, so 2i. So the square root of negative 4 is 2i, and we call that an imaginary number. This is an imaginary number. Another thing, what they're basically saying is this. They're saying the square root of negative 1 equals I. Okay? Now we covered this in Algebra 2 last year. I'm not sure if you other young men did, but we covered this in Algebra 2 last year. And so an imaginary number is a number with a letter I with it, and it comes from a situation like this where you have a square root of a negative number. Okay? Now you did not need to take notes on that. You're not going to be tested on that, but I wanted to refresh your memory as to what an imaginary number is, and here's why. Now we're going to get into the main topic, which is a complex number. So let me show you what a complex number is. Please write this down. A complex number is when you take a real number and put it with an imaginary number, and this is a complex number. So this right in front of you is what we call a complex number. It is a combination of a real number and an imaginary number. It's that simple, men. Please don't make it any harder than that. Now, it could be written, -4 minus 6i. It can be positive. There can be positives. There can be negatives. Whatever. In fact, I'm going to take it a step further. I can even say this. I can say, here is complex number 7. And you're like, whoa, that's not a complex number. There's no imaginary number with it. If I tell you that's a complex number, it's a complex number. Don't argue with me. I'm kidding. I'm joking, guys. If I tell you that's a complex number, then what it means is this. It just means that you have 0i with it. Okay? No big deal. If I say, hey, here's complex number -2i, and you're like, that's not a complex number. There's no real number with it. Well, then it's understood to be a 0. Okay? So, any combination of a real number and an imaginary number put together is a complex number. So do you understand what a complex number is? A real number and imaginary number put together. And now I need to tell you something else. All 4 of these, you need to know this, all 4 of these are written in standard form. Standard form. Let me give you a model as to what standard form is. Standard form is A plus BI. A being your real number and BI being your imaginary number. So when I ask you to write a complex number in standard form, the real number comes first and the imaginary number comes second. Some books take it so far that if they tell you to write a complex number in standard form, and let's say the complex number is 6, then they want to see that 0i. I'm not going to be that picky. I'm really not. But the point is, do understand what standard form is. Standard form is when the real number comes first and the imaginary comes second in a complex number. Okay? So there we go. That's pretty simple. Now, it even gets a little easier. Okay? This is pretty easy stuff today. I'm going to go as fast as I can. Here's what we're going to do today. We're going to learn to graph complex numbers. Very easy. We're going to learn how to find their absolute values. Very easy. And then we're going to learn to write complex numbers in trig form. That's decently hard. And then write them in standard form, and that's pretty easy. Okay? So those are our goals today. Let's go ahead and get started. When you're asked to graph complex numbers on a coordinate plane like this, remember this. Well, I shouldn't say remember, you didn't know this, but the y-axis has now become your imaginary axis, so make note of that. And the x-axis has now become your real number axis. We'll just call it your real axis, okay, to be a little short. So now that I've said that, men, it's this easy. 3 plus 2i is a complex number. Look at it like it's this, if that helps you. Just look at it like 3 comma 2, because remember, your real number is your x-axis, so that comes first. Your imaginary number is your imaginary axis, your y, so it comes second. So go over 3 and up 2. There. You just plotted that point. It's that easy. Over 3 up 2. Now you don't have to write it in parentheses form if you don't want to. You can just see positive 3, positive 2, over 3, up 2. That's up to you. Okay? Alright, let's do another one in green. Okay, this one here. We'll do this one in green. -4, -5. So I go over 4. 1, 2, 3, 4, down 5. 1, 2, 3, 4, 5. Isn't that easy? So we're graphing complex number on the complex number system. Okay? Alright, let's take a look, do this one in blue here. Now, notice there's no real number with this, so we really could say -3i is 0 minus 3i. Okay? So that means I go to 0 on the real axis and then down -3. It's the same thing as 0, comma, -3. Well, Mr. Earhart, how'd you know that was a complex number right there? There's no real, look at the directions. Graph these what? Graph these complex numbers. So I'm telling you they're complex numbers. So here's 2. It's a real number. There's no imaginary number with it. So we're going to put plus, well, that yellow doesn't show up, does it? That's really bad. 2 plus 0i. So that means we go over positive 2 and we go up 0 and down 0. So it's right there. Or you can look at it like this. 2 comma 0. We're moving on. I'm not going to make this more difficult than it is, okay? It's really, really simple. It really is. Okay, so graphing complex numbers. Now, let's talk about finding the absolute value of these complex numbers, okay? Really pretty simple. If I ask you to find the absolute value, and there's the absolute value symbols, if I ask you to find the absolute value of 3 plus 4i, it just simply means you take the square root, whatever the first number is, you square it, plus whatever the second number is, not the I, just the coefficient, you square it. So we would have 9 plus 16, which is 25, because 3 times 3 is 9, 4 times 4 is 16, 9 plus 16 is 25, and the square root of 25 is 5. It's always positive, by the way. There, you just found the absolute value of a complex number. Now you might say, well, Mr. Earhart, you're just throwing numbers at me. What does that mean? Well, I'm glad that you asked. I'm going to show you that in just a second. Okay? But first of all, let's go ahead and finish finding the absolute value of these numbers, and then I'll show you what you're really doing. Okay? All right, let's find the absolute value of this complex number. Well, I put my square root, my first number is -2, put it in parentheses and square it. And then even though you can't see it, there's a 1 in front of this I right here, so plus, and then a -1, and then we square it. So we end up with 2 times 2 is 4, -1 times -1 is 1, so 4 plus 1 is 5. So the absolute value of this complex number is the square root of 5. And now let's take a look at this one. Of course, I'm telling you they're complex numbers, so there's no real number, so I'm going to put a 0 there with it. So I really have 0 squared plus 4/5 squared, which of course would be 0 plus 16 25ths, because 4 times 4 is 16 and 5 times 5 is 25, and 0 plus 16 25ths would be the square root of 16 25ths. Now, if you left that your answer on a test or a quiz, I would take some points off. Anytime you have the square root of a fraction, you can split it up, so the square root of 16 25ths is the same thing as the square root of 16 over the square root of 25, and of course that would be the same thing as 4/5. That won't always happen like that, but in this case it did. Okay, now Mr. Earhart, that's all fine and dandy. That's really easy to do. I can now find the absolute value of a complex number. What was I doing? Well, here's what you were doing. Let me go back a page and show you. In trigonometric and complex numbers, when they ask you to find the absolute value of a complex number, see this red ink right here, that red, wrong color. See that red ink right there? And there's the red point for it right there. Here's what you were doing. If I asked you to find the absolute value of this number right here, pretend we graphed it, which we did. We plotted our point. There it is. All that you're doing is you're finding the length of that line. That's what the absolute value is. Okay? So when I ask you to find the absolute value of 3 plus 2i right here, and you go like this, you put 3 squared plus 2 squared, and you get the square root of 9 plus 4, the square root of 13. You just found the length of that line. I did? Yeah, and you know what you did? You might not realize it. You used Pythagorean's theorem. I mean, you were over how far? 3. You were up how far? 2. So if I asked you to find the hypotenuse of a right triangle using Pythagorean's theorem, you would square this, add them together, and take the square root. So everything I just said there, if you're lost, don't worry about it. I just wanted to show you what we're doing when we take the absolute value of a complex number. If you don't understand that, at least you can do this. Any of you can do what we did over here, which is when I ask you to find the absolute value of a complex number, you just take the square root of this number squared plus the other number squared, and then simplify. Anyone can do that, okay? And it's not that hard. So far we've learned to graph complex numbers and find the absolute value of complex numbers. Now it gets a little more difficult, okay? So far all the complex numbers have been in standard form. Now let's take a look at writing complex numbers in another form, and this form is called Trig Form. Now, don't take any notes, just sit back and watch for a second, okay? If I asked you to plot this complex number, it would be 1, and by the way, that should be a 1 right there, not an I. Let me fix that. So 1 plus I. So you would go over 1 and up 1. So there's the point. If there was another way that I could represent that point right there, pretend there's an imaginary line right here. If I could tell you what the angle was, and then tell you how long this line was, you would get the exact same point. Let me go over that again. If I told you this angle was 30 degrees, you knew you could measure a 30-degree angle, and I told you the length of this line was, I don't know, the square root of 2 or something like that, and you could measure that, you would get the exact same point. Now, you might have understood what I just said. You might not have. That's okay. I'm just giving you a little extra explanation before I teach you how to do this. When I ask you to write complex numbers in trigonometric form, that's what we're doing. We're going to find an angle and the length of a hypotenuse. And that's it. An angle and the length of a hypotenuse. It really is that simple, okay? So it takes a little bit of time. It's not super easy, but we can do this. So let's go ahead and take these three numbers and let's write them in trig form. Are you ready? Let's start off with this one right here. And then I'll erase all the work and we'll do this one and then this one, okay? So forget these for right now. We're not going to mess with those, okay? All right, here we go. Let's go ahead and draw a coordinate complex number system, and let's go ahead and plot that complex number. So I go over 1, up 1, put my point here. Now go ahead and draw that imaginary line that I told you about, and let's go ahead and draw our right triangle like we've done so many times. And after we do that, do we not know the length of this line right here? Sure we do. We went over 1, didn't we? And then we know the length of this line here going up because we know we also went over 1, then up 1. So we know the length of this is 1. So very quickly, using Pythagorean's theorem, or in other words, finding the absolute value of this number, very quickly I can find the hypotenuse of this triangle. I mean, you take one leg, square it, take the other leg, square it, take the square root of it. 1 times 1 is 1, 1 times 1 is 1, 1 plus 1 is 2, so square root of 2. So you just found the length of the hypotenuse. By the way, it's the same thing as just finding the what? The absolute value. So when you find the absolute value of this complex number, you really just found the length of the hypotenuse, and you're welcome to use that shortcut if you want to. Okay, I'm just trying to show you what we're doing here. So if you like steps, which a lot of you do, the first thing you do is you find the length of the hypotenuse. That's the first thing you do. And maybe I should have typed that up for you, but it's too late now. So find the length of the hypotenuse. And then next, after that, what we're going to do is we're now going to find this angle right here inside the triangle. We're going to find that angle, and that is so easy to do. I mean, it's going to be always use tangent. It's the best thing to use because you have these two numbers right here to use. The tangent of this angle, we're going to call it x. The tangent of that angle is opposite over adjacent, TOA, opposite over adjacent. So tangent of x equals 1. Now I'm going to very quickly pull up my table here. Does tangent ever give me 1? I know it's a little messy here, but yeah, right here. Tangent of 45 degrees equals 1. So now I know that my angle inside the triangle is 45 degrees. Okay? 45 degrees. Try to squeeze that in here. It's kind of hard to write. So let's quickly review. First, we found the length of the hypotenuse by finding the absolute value of this complex number, and then next we find that angle inside the triangle, which is 45 degrees. Now, what do you do with that information? It's really, really easy. Here's all that you do. The length of your hypotenuse goes right here, and then you put a parentheses, and then you always put cosine of this angle right here plus I sine of this angle here, and then close your parentheses. Now let's go over it again. Whatever your hypotenuse was, you simply put it here, and then inside the parentheses you will always put cosine first, always. You will always put I sine second, always, and that I just stands for imaginary number sine. You will always put sine second, and then the angle right here, starting from the x-axis and rotating to the hypotenuse, is the angle you put right here, and that's it. And by the way, if you wanted to check it really, really quickly and see if you were right, well, I guess we can get into that later. I'm not going to do that now, so let's just hold off on that. But this, you just took this complex number written in what form? Standard form, and you wrote it in what form? Trigonometric form. Not that hard, guys. Okay, I mean, I said it was the hardest thing we're going to do, but it's not that bad. Let's do a couple more and see how you do. All right, let's try the next one. Okay, let's go ahead and quickly graph this, get a picture of this complex number. Square root of 3, that's like 1 point something. So I'm going to go over a little less than 1, and then negative 1. So we'll put the point, we're just kind of estimating, it's no big deal. We'll kind of put the point right there. So we went over approximately 1 point something and then down negative 1. So there's the ordered pair. Now, remember, we always draw our right triangle on the x-axis. So there we go. And so I know my distance going across is what? Square root of 3. And my distance going down is 1. Don't put a negative 1. It's a distance in a triangle. We're going to call that 1, okay? Now, to find the hypotenuse, remember what to do. It's so easy. You simply square the first number. And then you square the second number and take the square root of that. It's just like finding the absolute value. So let's see. When you square the square root of 3, you get 3. When you square a negative 1, you get 1. 3 plus 1 is 4, so the square root of 4, 2. So there we go. Put a 2 on the hypotenuse. Very simple, guys. Find the absolute value of this, and when you do, that's the hypotenuse. So just like that, you found the hypotenuse. Pretty easy, okay? And now we have to find the angle on the inside there. So here's what we're going to say. We're going to look at this angle here. We're going to call it x, and we're going to say, always use tangent, guys. Tangent of x equals opposite, which is 1, over hypotenuse, or no, over adjacent, which is square root of 3. So opposite over adjacent, so 1 over square root of 3. Now we might be able to use our table, guys. I mean, 1 over square root of 3, we know, is the same thing as square root of 3 over 3. So let's see if there's an angle that we get for square root of 3. Here it is. Tangent of 30 is square root of 3 over 3. So we know the angle inside the triangle. Just leave that big wooden door open, guys. Thank you. The angle inside the triangle here is 30 degrees. Now, a lot of you think you're going to do this. Here's what a lot of you think your answer is. You're like, okay, Mr. Earhart told me to put my hypotenuse here. Bye, buddy. And then parentheses. And then you think you're going to put this. You're like, okay, cosine of 30 plus I sine of 30. No, 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 no. No, no. Remember, the other problem, we had the triangle right here. And we started here on the x-axis and we rotated up, and that was 45 degrees. Well, you always start on the x-axis, okay? But you rotate to the hypotenuse always. And that's what we did in the first problem, if you'll think about it. The triangle was in the first quadrant, so because the triangle was written here, we started here and we rotated up, and it just happened to be the same angle in the triangle. But you always start here and rotate all the way around, so it would be 2 cosine 330 degrees plus I sine 330 degrees. It'll always be plus 2 right here in the middle. It'll always be plus, always. In a second, you're going to see why we write it like this. You're going to see totally why, okay? In just a minute. So one more of these, and then one more quick section, and then we'll be done with this today. Okay, let's take a look at one more. All right, leave that door open, please. Thanks. All right, here we go, students. Let's take a look at our last one. Sorry about the interruptions there. My family's rushing out the door, and I'm trying to give last-minute instructions. All right, let's write this complex number in standard form. Let's write it in trig form very quickly. Negative square root of 10, that would be what? 3 point something. So 1, 2, 3, and then 10i would be way up here somewhere. You know, I'm not going to try to. We're just estimating. It's not really super important that we get the whole thing perfectly right. So in fact, I'm going to scoot these in a little bit. So all right, there we go. So 3 point something. So we go over our positive 1, 2, let's see, don't be negative. Sorry about that. So negative about 3 point something, then up 10, about there. It's no big deal. You don't even have to draw a picture if you don't want to. There we go. All right, so we draw our right triangle like we always do. So there's our point. Draw to the origin, draw your right triangle. We know we went over square root of 3, so the length of this is square root of 3. We know we went up 10, so the length of this is 10. Find the hypotenuse very quickly. Remember, you find the hypotenuse by taking the square root, and you square one number plus Boy, I'm really getting confused. There a problem, and I apologize, guys. Well, Mr. Arrow's getting old. You square negative square root of 10 squared plus 10 squared, and you will get this right here. You will get, when you square a square root, you get just a number on the inside. And when you square this, you will get 100. So the square root of 110. Square root of 110. Alright, now that might be able to be broken down. I'm not sure. I'm thinking. I don't think it can, though, actually. So we're good. Square root of 110. So there we go. And now all that you have to do is find the angle inside the triangle, and I've told you to use tangent. So tangent of x equals opposite over adjacent, so 10 over square root of 3. Now that's not going to be on your table that we have right here. It's not going to be there, so we use our calculator. So I'm going to turn my calculator on. We hit second tangent, and then 10 divided by the square root of 3. And we get 80.1, or just 80 degrees is sufficient. So 80 degrees. So here we go. Let's write our answer. Square root of 110, and then parentheses, and then cosine. Now remember, you start here and you rotate to the hypotenuse. So if that's 80, we went 100 degrees. So 100 degrees plus I sine 100 degrees. There we go. Cool, cool. Okay, very good. Moving on. Okay, so you've learned how to write a number that was in standard form and trig form, and now very quickly, I'm just about done, guys. This is it. Now I want you to learn to write a number that's in trigonometric form and complex form and standard form, and it's so easy, guys. You have no problem with this whatsoever. Trust me. Okay, this will be really, really easy. Okay, all you do is simply this: you just find the cosine of 120. Now, if it's one of your if it's one of your special angles, you got to use it. And 120 is. It is, Mr. Earhart? Yeah, it is, guys. You know what 120 degrees. If you rotate 120 degrees, you're left over with how much inside the triangle here? 60. So when I ask you to find the cosine of 120, you're really finding the cosine of 60 as long as you remember that cosine's negative in this quadrant. So the cosine of 120 is the exact same thing as finding the cosine of 60 as long as you remember it's negative, okay? And then here, sine of 120 is positive, as you can see right here. So it's the exact same thing. The sine of 120 is the exact same thing as the sine of 60 as long as you remember that it's positive in this quadrant. So I'm going to very quickly look at my table. The cosine of 60 is 1/2, and the sine of 60 is square root of 3 over 2. So the cosine of 60 is 1/2, so negative 1/2, and the sine of 60 is square root of 3 over 2. That's pretty easy. That's pretty easy. And now there's an I. Remember that I that was right here? This I should have been right here, and so that I is now down here. And now you simply multiply your 2 through. So 2 times negative 1/2 is negative 1, and then 2 times square root of 3 over 2 would be square root of 3I. There you go. That easy. So all you did was find the cosine of 120, put it right here, sine of 120, put it right here, and take this 2 on the outside and multiply it through. Pretty simple, okay? Let's take a look at one more, and then we're done. I want you to write this complex number in trig form. I want you to write it in standard form. Now I think we should first of all change 7 pi over 4 to degrees. That would be a help, and it's 315 degrees. So really what we have here is 315. Now 315 degrees might be one of your special angles. Let's see. If I rotate 315 degrees, how much do I have left? Yep, 45 degrees. 45 degrees. So it is one of our special angles, so you'll have to use exact numbers on this one. And remember, the sign sequence here is negative, positive, negative. Okay? So sine is going to be negative, cosine is going to be positive. So when I say to find the cosine, that should be a plus sign right there, by the way, not an equals. When I say to find the cosine of 315 degrees, and the sine of 315 degrees. That's the exact same thing as finding the cosine and sine of 45, as long as you remember the sine sequence. Now let's take a look. What is the cosine? I'm going to rewrite this real quick. So I have the square root of 8, and then instead of taking the cosine of 315, I'm going to take the cosine of 45. And by the way, when you take the cosine of 45 in this quadrant, notice it's positive, so there's nothing to change here. Now with the sine though, hold on. I know there's always a plus sign here. I get that, but hold it. We're taking the sine of 45, and that's going to give you a negative number. So it's going to be negative. Whatever you get out for the sine of 45, that's going to be a negative number. So put a negative sign here so you don't forget that. You can see that right here. Sine is negative, okay? So the cosine of 45 degrees is square root of 2 over 2. So I have this, and then square root of 2 over 2, minus, and then the sine of 45 is square root of 2 over 2. And is that right? Yeah, that's right. I should have known that. Square root of 2 over 2i, and now take your square root of 8 and multiply it through. Now watch carefully how I do this. It's really square root of 8 over 1. So square root of 8 times square root of 2 would be square root of 16. 1 times 2 is 2. And then minus square root of 8 times 2 would be square root of 16. And 1 times 2 is 2. There we go. Now we're almost done. We know the square root of 16 is 4, so we really have 4 over 2 minus 4 over 2i. And that, of course, would give us 2 minus 2i. 2 minus 2i. Okay, so there we go. Not too bad. I've tried to work as quickly as possible. Hope it's not been too long of a video for you. Here's your homework. It's very reasonable. 1 through 11 odd would be 6 problems. And then 13 through 29, look at this, it's every other odd. So you do 13, then you do 17, then you do 21, then 25, and then 29. So 13, 17, 21, 25, 29. So this is 5 problems here. So you have a total of 11 problems. Very reasonable. Probably take you about 20, maybe 30, about 15, 20, 25 minutes to do this assignment, okay? And this will be good practice for you, all right? So please get this done. Don't get behind on your integrity sheets. Call me or email me if you have any questions whatsoever.